Hello everyone, welcome to IITN Gate classes. So today we are going to start compiler design. Okay, so let me tell you one basic thing about this subject, that this subject is the smallest subject of Gate computer science syllabus, or you can say smallest subject or smallest topic of Gate computer science syllabus, and it is also very scoring subject. Okay, why I'm calling it as very scoring? Because first of all, this is very small topic, and also direct question will come in exam from this subject. Okay, direct questions will come. Okay, so and this subject you will feel also very interesting. Why this subject is interesting? Because if you know theory of computation subject perfectly, or you have good idea about this subject, then actually compiler design is nothing but the application part of TOC. Okay, so when you apply concepts, then I think you all feel that the concepts are very interesting. Okay, so that's why this subject is very interesting, because it's nothing but application of your TOC subject. Okay, and application part is really very interesting. You all already know this fact. Okay, so let's start this subject. Okay, and let me tell you weightage also. So minimum you can expect 3 to 4 marks from this subject. Okay, rather we should say 4 marks, minimum 4 marks. Okay, around 2 questions are always asked from this subject, and maximum it can go up to 8 to 10 marks also. Okay, so minimum is 4 and maximum is 10 marks you can expect from this subject. Okay, okay, so let's start this topic in pretty much detail. So what so if I tell you what is compiler design, actually let me say like this: tell me what exactly is compiler. Okay, so in one line, or you can say in one word, can you define what is compiler? Yes, I can easily define it. Say compiler is nothing but a language translator. Okay, compiler is nothing but a language translator. Language translator means what? It can translate one language to another language. Okay, so for example, we can make a compiler. Okay, we can make a compiler which will take one high level language as input, and it will give output as another high level language. So you cannot say that compiler always convert a high level language to low level language and so on. You will find this definition in various books, that compiler is a type of language translator which is used to convert high level language to low level language. Yes, you can say like this, but actually this is the most general form of compiler, that it converts high level language to low level language. Okay, but actually we should say compiler is nothing but a language translator only. Okay, so compiler basically convert one language into another language, and the language which we supply as input to the compiler, it may be some high level language, and the output, or you can say converted language, which compiler give, that can also be a high level language. That is, we can make a compiler which can convert C language program to Java language program, or Java language program to C language program, and so on. Okay, so you cannot say that it always convert a high level language to low level language. Okay, so we can make a compiler which can convert a high level language to another high level language also. So just one line, you should have to remember only just one word, rather I can say one word is, it is nothing but a language translator. Okay, so now let me give you a general, or you can say basic definition of compiler. Okay, so general definition, which you will find in most of the books. General definition is like this. General definition is, a compiler is a type of system software. Compiler is a type of system software. System software which is used. Compiler is a type of system software which is used to convert, which is used to convert a high level language program to low level language program, okay, which is used to convert a high level language program to low level language program. Okay, and this low level language program is, in most of the cases, it is assembly language program. Assembly language program. Okay, so you can define a compiler like this. So compiler is a type of system software. Okay, compiler is a type of system software which is used to convert a high level language program to low level language program. This is a general definition. Please keep this thing in mind that this is a general definition, and it does not mean that compiler always convert a high level language program to low level language program. This is not the case. Generally compiler is a language translator only, and it can convert one high level language to another high level language program also. Okay, so I think I have repeated many times, and by now you have got proper idea, okay, about what exactly is a compiler. Okay, so now you have already seen a new word, that is a system software. Okay, so let me define what exactly is a system software. Okay, so let me use a different slide. See, broadly we can have two types of softwares. Okay, softwares are of two types. One is application softwares. One is application softwares, and second is system softwares. System softwares. Application softwares are those softwares which are, you can say, which are designed according to utility of the user. Utility means what? Need. Okay, so according to need, the softwares which are developed according to need, these are known as application softwares. Okay, and so directly indirectly we are saying that without these softwares, computer can run properly. Okay, so computer can run. Without these softwares, computer can run. Okay, so example, according to utility or according to need, can you give me some examples of softwares which are designed according to utility or need? Utility is the synonym to need only. Okay, Hanji. So tell me some examples, like say calculator. Okay, we are using calculator in computer. This is a utility software. Without calculator also computer can run. And your word processing software like MS Word, MS Word, PowerPoint, and so on, games which you play in computer, and so on. So all these are examples of application software. And what exactly is a system software? System softwares are nothing but which are necessary. These softwares are necessary for proper functioning of computer. These are necessary for proper functioning of computer. Okay, proper functioning of computer. So what does this mean? Proper functioning means without these softwares computer cannot run. Without these softwares computer can't run. Computer can't run. Okay, so these are so can you give me some examples of system software? One of the basic software which you can imagine is operating system. Okay, and another is your compiler, linker, loader. Okay, don't worry about these terms, I will explain them properly. Compiler, linker, loader, etc. Okay, so in one line I can say what is the basic difference between the application software and system software. So the basic difference is, without these, if without any software, yeah, without the given software, if your computer can function or can run properly, that means it is an example of application software. And if you think that without this software computer cannot run properly, then that is nothing but a system software. Okay, I hope I have made the point properly, and I have given a proper justification to these definitions. Okay, I hope you all have noted down also. by now you have all noted down these notes also. Okay, so let me go to different slide. Next slide. Let's take the next slide. Okay, so I think by now everything is clear. Okay, so only one word, I can say only one word, that if without without that software computer can run, then that is application software. If without that software computer cannot run, that means it is a system software. Okay, so without compiler, obviously computer cannot run properly. Without operating system, obviously computer cannot run. Without linker, without loader, computer cannot run properly. But without calculator, without games, without MS Word, obviously computer can run, or computer can function properly. Okay, so in one word, the basic difference between, so if somebody asks you about what is the basic difference between application and system software, so you can say only one line, that system softwares are necessary for proper functioning of computer. That means without these softwares computer cannot function properly. Okay, and if computer can function properly without software also, without that software also, then it is application software. Application means what? The word application itself means utility or need. So according to utility, or you can say according to need, the softwares which we are going to develop, or which the softwares which we are going to design, these softwares are known as application softwares. Okay, so let's move to next slide. Okay, so in the definition we have cleared this word system software. So compiler is a type of system software which is used to convert a high level language program to low level language program, and this low level language program is generally an assembly language program. Okay, okay, so now let me give you some more idea. So I hope now this definition is crystal clear to everybody. So compiler is a type of system software which is used to convert a high level language program to low level language program, and this low level language program is generally an assembly language program. Okay, so let me tell you the three stages of compilation. So how exactly compilation is done? Okay, so first, so let me write this thing, three stages in compilation. Okay, so in the first stage, high level language program is given as input to compiler. Okay, in the first stage, high level language program is given as input to compiler, and compiler will convert it into assembly language program. Assembly language program has extension ASM. So in the short way, I am writing it as ASM. Okay, now in the next stage, this assembly language program will given as input to assembler. Okay, given as input to assembler, and assembler will give us machine code. Okay, so this is your second stage, and in the third stage, machine code. Okay, to this machine code, user will give some input, and it will receive some output. Okay, so tell me one thing, why we are making a program? Okay, so you are designing a program, or you are writing some program in say C language. Why you are writing this program? What is the main goal of the program? The main goal of the program is it will convert the input to some output. Say this is your program. Okay, so this is your program, you will give some input to it, and you will receive some output from it. Okay, say let's say you give the number as 5, 10, 9, and the output is 5, 9, 10. So that is nothing but sorting. Okay, so you are sorting the given numbers. Okay, so this is an example of a program, or you can say given number is prime or not, and so on. You are making lots and lots of programs in your daily life. Okay, so program is not so the main aim of writing program is you give some input and you receive some output from it. So this is your main goal. So how exactly this is done, I have given you idea that there are three stages. Okay, so in the first stage, high level language program is given to compiler, and we will receive as a output assembly language program. This assembly language program is given as input to assembler, and assembler will give us machine code, and to this machine code user will give some input and receive some output. Okay, so these are the three stages of compilation. Okay, I hope this concept is crystal clear to everybody. Okay, so you have also heard the word interpreter. So what is the basic difference between compiler and interpreter? Let's study that difference. So in compilation, if you are using a compiler, then in 3 stages this compilation process is done. Okay, so in the third stage you will give some input and you will receive some output. Okay, so but what about your interpreter? Let's do this thing also. Okay, so let me change the slide. I hope you have noted this down. Okay, so in case of interpreter, see what exactly is happening in case of interpreter. In case of interpreter, the entire process is done in only one stage. Only one stage. So we will give, so one stage means what? We will give a high level language program. Okay, we will give a high level language program as well as input to the interpreter, and interpreter will directly give us output. Okay, so you may think that interpreter is very fast, because in case of compiler we have done 3 stages, but in case of interpreter, to the interpreter we are giving 2 input, that is high level language program also and input also. Say the program is addition of 2 numbers. So imagine like this, program is addition of 2 numbers. Okay, addition of 2 numbers is the program, and the input are 2, 3. So interpreter will directly give you output 5, that is 2 plus 3 is 5. Directly it will give you output. Okay, so you will give high level language program as well as input to the interpreter, and interpreter will directly give you output, that is 5. But in case of compiler, you are not giving input, you are not giving inputs, you are giving only high level language program as input to the compiler. Input means for 2 and 3, the numbers you are not giving as input to the compiler, you are giving only addition of 2 number program to the compiler, and it will convert it into assembly language program. Then assembly language program is given to assembler, and it will be converted to machine code, and to this machine code you will supply input as 2, 3, and machine code will give you output as 5. Okay, so what do you think, which is more fast, compiler or interpreter? Okay, I hope you have studied all these things, and you may give answer as okay, sir, we already have studied that compiler is faster, but according to the concepts which you have given, we are thinking that interpreter is more fast. Why it is faster than compiler? You may think that it need only one stage, that is you are giving high level language program and input to the interpreter, and the interpreter is directly giving you output as 5. So obviously this is more fast. Okay, but no, actually it is very slow. Okay, actually it is slow. Why it is slow? So just imagine one thing here. In the case of compilation, you know that we are using 3 stages. So now I will give you reason that why we are using these 3 stages. Okay, so first high level language program is converted to assembly language, then assembly language program is converted to machine code, and to this machine code you are giving output input 2, 3, and output is giving as given as 5. Okay, now next time when you give input say 4 and 6, then output will be 10. Okay, now you do not need these 2 stages at all. So these 2 stages are needed only for the first time. Okay, for the first time you need these 2 stages. Okay, and once you got the machine code, then you can give different inputs and you can receive different outputs. Okay, directly you will give input and you will receive the output. But what about this interpreter case? In this case, since you are giving high level language program as input as well as the input which you want to give to the program, and interpreter is giving you output, that means what? Next time when you want to give input say 6, 4 and you want output 10, then interpreter will again interpret the same high level language program, and input will be given as 6, 4 and output will be given as 10. So again and again, that so directly indirectly I want to say that in case of interpreter, again and again this high level language program will be converted to machine language, and machine language program will be given input say 6, 4 and output will be given as 10. So if you give next input say 15 and 5, output will be 20, but you won't receive these you won't receive 20 as output from 15,5 directly. First, interpreter will convert this high level language program to machine language, and then to that machine language 15 and 5 are given as input and 20 will be received as output. So what I want to say you is the fact that in case of interpreter, these three stages are merged together, and hence whenever input is given, all these three stages work will be done again and again. Okay, but in case of compiler, only the last stage work is done again and again. Okay, and that is nothing but your processing itself. Okay, so processing, obviously you have to do processing again and again. Whenever you are giving some input, you want some output, then you have to do processing. Okay, so the only the necessary things are repeated in case of compilation, but in case of interpreter, necessary things are obviously repeated, but unnecessary things are also get repeated. That is, this high level language program will be converted again to machine language and so on. You really don't need all these kinds of things, but interpreter is doing all these things again and again. That is, unnecessary things are done again and again by interpreter. Hence, this is very, very slow. I hope I have made the concept crystal clear to everybody. Okay, so that's why interpreter is slow. So by seeing directly or by in one glance, you may think that interpreter is very fast and compiler is very slow, just because compiler needs 3 stages but interpreter need only 1 stages, but it is not the case. Okay, in case of compilation, no doubt we are using 3 stages, but these first two stages are used only once, and after that, when we get the machine code, you can give different inputs and you can receive different outputs. But in case of interpreter, whenever you want to give different inputs, then again this high level language program will be converted to machine language. Okay, so unnecessary steps are done again and again, and hence interpreter is very, very slow. Okay, so I hope I have made the point very clear. And one again, you know the basic difference between compiler and interpreter, that the compiler, okay, so let me use different slide. Okay, so no problem, I will give you some basic differences between compiler and interpreter. Okay, and then we will jump to next slide. So compiler, first of all, you have seen from this diagram that in case of compiler, we are not supplying inputs. Okay, and compiler is not giving some output. Okay, it is just giving you assembly language program, and input and output are given to the machine code. Okay, so that means what? Compiler cannot produce output. Roughly, you can say giving you idea that compiler does not provide output, but interpreter provide output also. Okay, how? You have already seen from this diagram that interpreter is giving you output. So you are giving high level language program and input to the interpreter, and the interpreter is giving you output. But in case of compilation, you are not giving input to the compiler. Okay, and compiler is not giving you output. Okay, so rather the input to compiler is your high level language program only. The inputs are these, say 2 or 3 numbers. Input here means that the numbers which you want to sort, or the numbers, whatever thing you want to do. Okay, so whatever is your exact input to the program, that input you are not giving to compiler. You are giving compiler as input. The input to the compiler is only the program. Okay, and not the input to the program. Okay, I hope I have made the point clear. And the compiler will give output as assembly language program. It is not giving you the end result. That is, it is not giving, if you are giving 2, 3, and it is not giving you output as 5, but interpreter is giving output as 5 also. Okay, so this is the very basic difference between compiler and interpreter, that compiler does not produce output, but interpreter produce output also. Second point, compiler is obviously very fast. Okay, compiler is fast, but interpreter is slow. Okay, I hope I have already explained this point. You already by now you already know this fact that compiler is fast and interpreter is slow. Okay, compiler convert the program, entire program at once, whole program at once, whole program at once, but interpreter go line by line basis. Okay, what is the basic meaning of line by line basis? I hope you know this fact. Okay, so let me say this way. Let me say this thing this way. Say this is your high level language program. So compiler will convert this program into assembly language program. Okay, so what do you think? At once means what? Obviously compiler is also going line by line basis, but whenever it find error, say this line has some error, then it will display the error, say this is your error, and it won't stop, it keeps on compiling the program. Okay, so it will keep on compiling the program, it won't stop anywhere in between. That is, if it finds some error, then it will show the error that say this line has this error and so on, but it won't stop, it will keep on converting the program into assembly language. But in case of interpreter, the line by line basis means that say these are some lines of the program, once interpreter finds some error, it will stop, it won't compile the rest of the program, sorry, it won't interpret the rest of the program. Okay, so once interpreter find an error in the line, then it will stop immediately and show the error, and it will immediately stop and it won't interpret the rest of the lines of the program. But in case of compiler will not stop, it will keep on compiling the program. Okay, so this is the basic meaning, that compiler whole program at once, but interpreter works on line by line basis. Okay, okay, so the next difference, let's move to the next difference. See, compiler, debugging 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 is difficult. Okay, debugging is difficult in case of compiler. Okay, why it will be difficult? Why it will be difficult? Can you give me some idea? But in case of interpreter, debugging is easy. Okay, let me talk about very basic things. First of all, tell me what is debugging. Okay, see, there are two basic terms which are used. Okay, and these terms are, let me use different slide. Okay, let me use different slide. First term is testing, and the second term is debugging. Okay, can you tell me the basic difference between these two terms? Testing means finding error from the program. Testing means finding errors from the program, and debugging means removing error from the program. Okay, let me give you some basic you can say basic introduction, or you can say basic idea, or you can say basic example, then you will find these terms very easy. So testing means finding errors and debugging means removing error. Okay, so let us suppose you are making a program for finding greatest of three numbers. Okay, you are making a program of finding greatest of three numbers. Okay, so, and you have already made the program and you are giving some input to the program. Let us suppose you give input as 5, 9 and 10, and the program is saying that 10 is the greatest. You say okay, the program is fine, but no, please try to give some other inputs also. Let us suppose next time I give input as 5, 10 and 9, and the program is saying that 9 is the greatest number. Then you conclude that program has some error. Okay, and again try to give some more inputs. Say you give input as 10, 9 and 5, and compile and the program is saying yeah, output is 5 is greatest. Then you came to know that the program is always giving the third number as the highest number. Okay, so these different inputs which we are giving to the program, this is known as testing. So testing means you are giving different inputs and you try to find some error in the program. So testing means what? Finding error from the program. You are trying to find something. Okay, and debugging means removing error from the program. Removing means what? Once you know that there are some error in the program, you will go to the coding part of the program and you will try to change the code of the program, and that process is known as debugging. Okay, so now come back to the differences. I said debugging is difficult. Now, can you guess why in case of compilation debugging will be difficult? Obviously, it will be difficult because compiler will give you list of lines in which some errors are present. So these are lines in which errors are present. So you will go to line and you will try to find what is the error and so on. But in case of interpreter, as soon as interpreter finds some error, it will stop and say there is an error. So obviously debugging will be easy in this case. Okay, so if program has say 100 lines, say program is of 1000 lines. Okay, assume that the program is of 1000 lines and 100 lines have errors. 100 lines have errors. So all these 100 lines will be displayed and compiler will say this line has this error and so on. So obviously things will get messy. Okay, but in case of interpreter, if you give 1000 line program and as soon as it find an error in the line, then it will immediately stop. Okay, so that's why we say that debugging is easy in case of interpreter, but it will be difficult in case of compiler. Okay, okay, and last difference. What do you think? Which program will need which you can say software will need more memory, compiler or interpreter? By the memory I mean RAM. Okay, which need more RAM, compiler or interpreter? I think you have right guess that compiler will need more RAM. Okay, compiler will need more RAM. Why compiler will need more RAM? Because it has to maintain a list of lines in which errors are present. But in case of interpreter, we do not need this list and so on. Okay, so that's why interpreter need less RAM. Okay, so these are the basic 5 differences between compiler and interpreter. Okay, so now let's move to the next slide. Basic part is over. Now we will jump to steps in compilation. Okay, so note it down, kindly note it down these points. Okay, so let's move to the next slide, that is steps involved in program execution. Steps involved in program execution. Okay, what are the various steps which are involved in program execution? That means whenever you try to execute a program, what exactly happens? So let me take example of C language, because C language is in your GATE syllabus. So you write the source code. Okay, you write a program in C language that is known as your source code, and source code extension is .c. Okay, .c. Okay, so now this source code will be given as input to preprocessor. Okay. Now this preprocessor will convert this source code, that is C language program, to pure high level language program. Okay, it will convert it into pure high level language program, or you can say pure HLL, or you can say modified source code, pure HLL or modified source code. Okay, so input to preprocessor will be the source code, that is C language program, or you can say the program which you have written, that is .c extension file, and preprocessor will convert the source code into pure HLL or modified source code. Okay, now this pure HLL program is given as input to compiler. Okay, this will be given as input to compiler, and this compiler will convert this pure HLL language program into assembly language program .asm. Okay, okay, now this ASM, or you can say assembly language program. Okay, I have already told you that compiler will convert a high level language program into assembly language program. This is the general case. So we are discussing a general case, that is we have a program and what are the basic steps involved in the program execution. So compiler will need input as a pure high level language program, and that will be converted into assembly language program. Okay, so compiler will convert pure HLL, yeah, pure high level language program into assembly language program. Don't worry about what exactly is pure HLL and what is preprocessor and so on. I will teach you all these things, but first let me make the basic diagram, or you can say basic flow chart. Then I will explain each and every word properly. Okay, okay. So to this assembly language, so this assembly language program will be given as input to what? Assembler. Okay, so this assembly language program will be given as input to assembler, and now assembler will give relocatable machine code. Relocatable machine code. Okay, so assembler will take input as assembly language program, and it will give output as a relocatable machine code. Now this relocatable machine code will be given as input to linker slash loader. Okay, and we will get target machine code. We will get target machine code. Okay, so to this machine code, user will give some input. To this machine code, user will give some input and receive some output. Okay, I have already told that what is the basic need of writing a program. Yeah, you can say why we are writing a program, so that we can give some input and receive some output. Okay, so to this machine code, we will give some input and we will receive some output. Okay, so these are the basic steps involved in program execution. Okay, so the first thing, let me explain you each and everything in this flowchart properly. So source code you already know, you have write a C program. Okay, what is this preprocessor? Preprocessor is I think you have already studied in C language course. Preprocessor is your macros. Okay, we have two preprocessor. The first is macro, okay, and file inclusion. Okay, let me write in the serial way. First is file inclusion, and the second is macro. Okay, file inclusion and the second is macro. What is file inclusion? File inclusion is hash define. Okay, hash include. File inclusion is hash include. Hash include. And what is macro? Macro is hash define. Okay, so I think you have already studied C language and you have used this line, hash include stdio.h, hash include stdio.h. Okay, so what does this mean? That this header file, stdio means standard input output .h means header file. This is extension of header file. So this header file will be pasted in your program. Pasted in your program. Okay, this is the basic meaning. Pasted in your program. So this file will be pasted as it is in your program. So before compilation start, preprocessor will paste this entire file in your program. Okay, and only after pasting your compilation process will start. Okay, so after pasting this file in your program, you will get a pure high level language program. Okay, okay, now similarly you have used macros also. Okay, and I think you have also used this file, na? Hash include conio.h. Okay, hash include conio.h. Conio means what? Console input output. Console input output. Console means what? Keyboard and monitor are together known as console. Keyboard and monitor are together known as console. So console input output means what? Input from keyboard and output from monitor. Okay, so input from keyboard and output from monitor. So it include various functions like get ch, get che, and so on. You have already studied all these things in C language also. Okay, so hash include conio.h and so on. So hash include conio.h means what? This console input output header file will be copy pasted in your program. So before compilation, this file will be pasted in your program. Okay, and this file contains various functions, various library functions, which deals with input from keyboard and output on monitor. Generally, this is the case. So you will say that, oh, sir, obviously we always give input from keyboard and output on monitor. No, this is not the case always. You have already studied file handling in C language also. So input may come from file also. So for input, we have two choices: input from keyboard or input from the file. Similarly, output also on monitor, or you can receive output in file, or you can directly print output on printer also. So you have various functions and so on. We are not going in detail of all these things. Obviously, we are doing compiler design. We are not doing C language. Okay, so let me stop here itself. So we are not going to detail. We are not going into details of these things. Okay, so the basic idea you have got, that file inclusion means what? Hash include, and this means what? Entire file will be pasted in your program. Okay, next is macro. Macro means hash define. Let me use different slide. Okay, so I think you have used statements like hash define and 10, like this: hash define and 10. Okay, so what does this mean? Say then after that you have used, say, void main, and you have written the program dot 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 dot, something like this. Okay, so in the program, wherever you have used the n, this n will be replaced by 10 before compilation. So let's say you have used, say, int x, and x is equal to n. So what does this mean? Now before compilation, this n will be replaced by 10. Okay, so this all things will be done by preprocessor itself. So preprocessor will do all these things. So first thing preprocessor will do, copy paste the header files. Paste header files in your program. If you want proof that these header files are pasted in your program, actually you won't be able to see the header files got pasted. Actually, if you want proof, then in your you can say C language program, I think you use control F9, control F9 to run the program, or you can say compile the program. So in place of using control F9, you use only F9 key. When you use F9 key, then it will give you summary about the lines compiled. You have written, say, a program of 510 lines, but the lines compiled will be 500 something. So from where this 500 line came? This 500 lines came just because of the header file. Okay, that is the stdio.h. Okay, so I think you have got the proof also that these files are pasted. Okay, so preprocessor first task is paste the header file. Okay, and the second is the macro part. Okay, so the macro part is this thing. So int x, so x is equal to n. So before compilation, this n will be replaced by 10. So I think you already know the terms. So n means what? N is what? N is macro template. N is what? Macro template. Macro template. And what is 10? 10 is macro expansion. Macro expansion. Okay, so before compilation, macro template is replaced by macro expansion. Before compilation, macro template is replaced by macro expansion. Okay, so replacing the macro template by macro expansion, this all is also done by what? By preprocessor. So let me write. So replace macro template by expansion. Replace macro template by macro expansion. Macro template by macro expansion. Okay, so I hope you got clarity about what is what is exactly preprocessor. So preprocessor is doing two tasks. First, it will copy paste the header file. Okay, so let me use the slide. First, it will paste the header file in your program, and second, it will replace the macro template by macro expansion. Okay, so after doing all the after doing these two things, we get pure HLL program. Okay, now this pure HLL program will be given to compiler and it will give you assembly language code as output. Okay, okay, so let me give you some idea about this macro template and macro expansion. Let me give you some more important points, because these points may came in exam, and after that we will finish off our lecture we will finish off our today's lecture, and in the next lecture itself we will give you proper detail about macro template, macro expansion, and so on. Okay, so let me share some basic points. Okay, so the first point is, what is the advantage? What advantage you are getting? What advantage you are getting with the help of this macro template, macro expansion, and so on? You can directly write this 10 also, na? In the program, in place of writing x is equal to n. Why you are writing like this? You can argue that we can use directly x is equal to 10. Why we are not doing like this? Okay, so why we are using first x is equal to n and then n will be replaced by 10? So in place of to save the time, we can directly write x is equal to 10, but we are not writing like this. Why? That is the directly I want to say what is the advantage of this macros. Okay, so advantage is you can easily edit the program. Easy edit, short in short, I am writing easy edit. Why easy edit means what? So today you are writing it as 10, in the next day you want 15 or you want 20. So if you have written multiple times, say in the program you have written multiple times 10 10 10 10 dot dot dot, dot. In various lines you have written 10 10 10, and you want to make them as 15. So in each and every line you have to move and edit the program, and you will say that 10 is replaced by 15 and so on. But if you have used the concept of macros and you have defined, let me use different slide. You have defined hash define and 10, hash define and 10, and you have written multiple times. In place of 10 you have written multiple times n only. Okay, so you have written n somewhere in the program, somewhere in the program, and so on, like this n. Now you want to make it 20, just replace here itself, that is replace 10 by 15. So in the program automatically all this n will be replaced by 15 only. Okay, so you will be easily able to edit the program with the help of macro. Okay, this is the very basic and the biggest advantage of using macros. Okay, now next you can argue that, sir, why you are using macros? We can use variable also. So in place of defining hash define and 10 and 15, you can define variable like int n is equal to 10. Okay, so in entire program you will use these things n and n, and when you want to edit, then 10 will be replaced by 15. Okay, so yeah, you can use this also, but the main problem is that this n will be a local variable of your program. Okay, this n will be local variable of the program, but you can argue that, sir, why it is local? You can define this globally also. So before starting main, okay, you can define like this, int n is equal to 10. Now what? Okay, so now next point will be, I will say accidentally you can change this n in the program. Okay, like this, say if you write say somewhere n here, then n here, then n, and accidentally you change here n is equal to 15, and then you have written some n here and so on. So all these n will be actually equal to 10. Okay, just because you have defined a global variable, and these n will be 15. Okay, so it will become a mess for you. So accidentally you can change this. So now you can argue, sir, we can change this also, but no, we cannot change macro like this. Okay, so for example, if you want to change, for example, you write say n is equal to 15, somewhere in the program you have defined hash define and 10. Let me use different slide. Note it, please note it down, all these things. Let me use different slide. Okay, so you have defined say hash define and 10, hash define and 10, and somewhere in the program you return n is equal to 15. Now remember my words, I use the word before compilation, this macro template will be replaced by macro expansion. So before compilation, this n will be replaced by 10. So actually you are writing 10 is equal to 15. So 15 cannot be assigned to 10, hence this will be a syntax error. So you cannot change macros. Okay, once you have defined n10, then you cannot change n in the program. If you try to change it, then syntax error will be thrown by compiler, just because this n is a constant quantity. You cannot change this, because before compilation, see, compiler won't see n, compiler will see 10. Okay, because before compilation itself, n is replaced by 10. Preprocessor has already replaced this n by 10. So compiler will see 10 and it will say 10 is equal to 15, and it will throw you error. Why? Just because it will say that left hand side of assignment operator, this is an assignment operator now, so left hand side of assignment operator will be a single variable. How this constant came here? Okay, so it will give you error. So hence, so basic difference you have got, that this n is a constant. And let me show you one more interesting fact. Okay, so this n is a constant quantity. This n is constant. And one more interesting fact is, this n is, we call this n as symbolic constant. Why we are calling it as symbolic constant? Let me explain you properly why I am calling it as symbolic constant. See, for this n, memory is not allocated. You won't say that 2-byte memory or 4-byte memory is allocated for n. In fact, no memory is allocated for this, and hence we are calling it as symbolic constant. Okay, so for proof, if you write size of n, what do you think? What will be the output? You will say, sir, you have already told that this is symbolic constant, no memory is allocated, so size of n will be 0. But no, output won't be 0. Output will be 2 bytes. If you consider that constant need 2 bytes, then output will be 2 byte. Why? Because compiler won't see n. Again, I am saying, again, I am repeating again that before compilation, this n will be replaced by 10. So basically, you have written size of n, but actually compiler will see the statement as size of 10, and size of 10 will be 2 bytes. If you think that if your compiler need 2 bytes for integer constant, then answer will be 2 bytes. So this 2 byte is not coming just because size of n is 2. No, it's coming because size of 10 is 2. Okay, I hope I have made the point pretty clear to all of you. If you want proof of this statement, then you can write this also, hash define and 2.5. Okay, now size of n, if you try to print size of n, okay, size of n, then it will show 4 bytes. If you think that 4 bytes need for the for this floating point number and so on, actually by default floating point numbers are treated as double, you all know in C language. So answer will be 8 bytes. It won't be 4, it will be 8 bytes, because it is a floating point number, and every floating point number by default is double and not float. Okay, so answer will be 8 bytes. Okay, so now you cannot say that n needs 8 bytes. No, it's coming just because it compiler will see in place of size of n, compiler will see size of 2.5. Size of 2.5 will be 8. Okay, so by now you have got crystal clear idea about let me use different slide. Okay, crystal clear idea about difference between hash define and 10, hash define and 10, and int n is equal to 10. So first difference will be no memory, but obviously this is a variable, so it need memory. Okay, and by default scope will be local, but you can define global also. Okay, and here scope is always global. Please keep in mind this thing, scope is global. Scope is always global means what? Say if you define this thing in main also, na, void main, you write some lines and then you define hash define and 10. if you write like this also, even then its scope will be global. Why? Just because before compilation, see, before compilation, preprocessor will come and it will replace all the n with 10 itself. So even though you have defined this thing locally, that is in the scope of main, but still it will be treated as globally. Okay, because preprocessor will you can say will replace all n by 10 itself. So its scope is always global, but its scope can be local or global depending upon where you have defined. If int n10 is defined in main, then its scope will be local, and if n10 is defined, int n is equal to n is defined before main and so on, then its size its scope will be global. Okay, okay, and here no memory, but it needs memory. Okay, okay, so I hope I have made the point clear. So let's stop here itself. Okay, so in the next class we will study some more basic detail about this macro and so on, and I will give you proper detailed knowledge of some example of assembly language programs, then what is exactly is relocatable machine code, what is linker, loader, and so on. We will study all these things in next lecture. Okay, thank you so much. Bye bye.